Hello friends, I'm Samir and I welcome you all to your own YouTube channel Aryavata. Friends, today in this video we are going to discuss multiplication theorem for conditional probability, which is shortly called multiplication rule. So multiplication theorem for conditional probability will be our today's topic of discussion. For that, as it is the case of conditional probability, so definitely we need at least two events. So let's take two events of the same sample space and the events be A and B, where the event A at least is not equals to phi. Then the conditional probability of B subject to A, as we know its formula is probability of B intersection A divided by probability of A, which is also equals to probability of A intersection B divided by probability of A. Now if we multiply this denominator, which is probability of A, with the conditional probability, if we cross multiply it, then we will get the probability of A intersection B or the probability of B intersection A, because both are same. So after cross multiplying, we will obtain another form of probability, which is probability of A intersection B, which is also equals to probability of B intersection A, which is equals to probability of A multiplied with conditional probability of B subject to A. So here we can see, to get the probability of two events intersection, we'll get the result as a product of two different probabilities, where the first event's probability is multiplied with the conditional probability of the second event. That's why this formula is called multiplication rule, because two probabilities are multiplied and by that we are getting the probability of intersection of two events. Okay. Now to represent it verbally, we can say that the probability of the joint occurrence of A and B, that means the probability that A and B both will occur together, which is equals to the probability of the event A multiplied with the probability of the event B subject to the occurrence of the event A. This is the verbal meaning of this multiplication rule. So we came to know that how it is called multiplication rule, because two probabilities are multiplied, and what is the output or for which purpose this rule is applied. This rule is applied for the joint occurrence of more than two or more than two events simultaneously. In this case, this formula will be applied. Now if we take three events of the same sample space, then what will be the multiplication rule for three events? Let us discuss multiplication rule for three events. For that, let A, B, C are three events of the same sample space. Then probability of A intersection B intersection C will be equals to probability of A multiplied with conditional probability of B subject to the event A, then multiplied with conditional probability of C subject to A intersection B. In place of A intersection B intersection C, we can shortly write A, B, C also. It's not that A, B and C are multiplied together. Here only the intersection symbol is not written, it is invisible, but it is obvious. We can, so if three events are multiplied without any symbol in between them, then usually we will come to know that it is about intersection of three events. So now the same law can be written as this also. we can omit the intersection sign here and we can get the law. Now, there is a generalized multiplication rule. That means, say there are n number of events of the same sample space. For events a1, a2 up to an of the same sample space. Now, the probability of a1 intersection a2 intersection up to intersection an will be equals to, in the similar manner as above, it will be equals to probability of a1 multiplied with probability of a2 subject to a1 multiplied with probability of a3 subject to a1 intersection a2 and so on up to the end, provided the last probability should not be 0. Now, this is the whole theory of our multiplication rule for conditional probability. Now, to know more about it, let's discuss few problems on it which will make us more clear about it. Now, example 1, where the question says 2 cards are drawn at random from a pack of 52 cards. Without replacement, find the probability that both the cards are kings. Now, there is a pack of cards, 52 cards, out of which we have to draw 2 cards randomly, means 1 by 1, and that is without replacement. That means we'll pull the card and we'll keep it, will not put it again in the bundle. Then what is the probability that both the cards are king? This is the question. So, to solve it, let's take 2 events, event A and event B. Let event E be the event that the first card is a king, and event B be the event that the second card is also a king. Now, the probability of A, that means the first card is a king, will be equals to 4 by 52, because the number of cards in the bundle is 52 and number of kings is 4. So, it will be 4 by 52. Now, after getting a king and without replacing it, the number of cards in the bundle will left as 51 and the number of king in that remaining bundle will be 3 kings. So, the probability of B subject to A, that means after choosing a king, if you again want to get another king in the second draw, in the second selection, then its probability will be the remaining number of kings, that is 3, by the remaining number of cards, that is 51. So, probability of B subject to A is 3 by 51. So, the requirement of the question is we have to get both kings in both draws, 1 king in both the draws. That means we have to find out probability of A intersection B, and that is equals to, by multiplication rule, it is probability of A multiplied with probability of B subject to A, whose values we have already calculated. So, we will put it and we will multiply and we will simplify it, and the answer we are getting is 1 by 221. Okay friends, now come to the example 2. Here 3 cards are drawn at random from a pack of 52 cards, that is without replacement. Now, what is the probability that all 3 cards are queens? So, here 3 cards are drawn 1 by 1 from that bundle of 52 cards, and that is without replacement. That means after each draw, 1 card will be less in the bundle. The number of cards in the bundle will reduce by 1 after each draw, because we are not replacing it. So, the question is to find the probability that all the 3 draws will result in 1 king. That means 3 queens will find in 3 draws. So, let's take 3 events for that. Let A be the event that the first draw is a queen. Say B be the event that the second draw or second card is a queen, and C be the event that the third card is also a queen. So our requirement is the probability of A, B, C, that is the probability of A intersection B intersection C, which is by multiplication rule is probability of A multiplied with probability of B upon A multiplied with probability of C upon A intersection B. So now first of all, probability of A, that the first card is a queen. So number of queens in the bundle is 4 and total number of cards is 52. So it will be 4 by 52. Now after each draw, one card will be less and one queen will be less. So probability of B upon A will be 3 by 51 and probability of C upon A intersection B will be 2 by 50. So if you calculate it, you will get the answer as 1 by 5525. This will be your result. Now let's come to example 3. Example 3 is basically the same question as that of example 2, but here the question is with replacement. That means after each draw, we'll put the card again in the bundle. That means the number of cards will be always remain as 52. So here the probability of A, B, C is same as the previous formula, but here as the number of cards in the total bundle is not decreasing, it will always remain the same, and number of queens always remain as 4 in the bundle. So it will be probability of A multiplied with probability of B multiplied with probability of C, that is 4 by 52 multiplied with 4 by 52 and multiplied by 4 by 52. Always the number of card will be 52 in each draw and number of queen will always remain as 4. So after calculating, we will get the result as 1 by 2197. So you can see the answer is changing in both the questions only with the method that here we are choosing the card without replacement and here we are drawing the card with replacement. Okay friends, now come to example 4. Here we have two bags, bag 1 and bag 2. The first bag has 4 white balls and 6 black balls, and the second bag has 5 white balls and 7 black balls. Okay. Now suppose that a ball is randomly picked from the first bag and put in the second bag without knowing its color. If you now pick a ball from the second bag, what is the probability that it is a white ball? Okay friends, bag 1 and bag 2, we have two bags. Bag 1 has some number of white and black balls and bag 2 also has some number of black and white balls. Now one ball from the bag 1 is drawn randomly without knowing the color and it is being put in the second bag. Now if we draw a ball from the second bag, the question is that what is the probability that that particular ball will be a white ball. So here we have to find out the possibility of a drawing of a white ball from the second bag. Okay friends, so for that let's first of all name some events which will be required here. Let W1 be the event that the first draw is a white ball. B1 is the event that the second draw is a black ball. W2 the event that the second draw is a white ball, and B2 be the event that the second draw is a black ball. So in this way we have the 4 situations as follows. That means W1 intersection W2, that means 2 white balls or 1 white ball. First is the white ball, second is the black ball in the second draw. First draw will be the black ball, second draw will be the white ball, and fourth case will be first draw will be a black ball and second draw will also be a black ball. Now the probability of each of these events can be calculated by multiplication rules as follows. Now probability of W1, actually we don't need all these cases, we need only 2 cases out of that. Our requirement is the probability of that the second ball is a white ball, second draw is a white ball, that is the I and triple I cases. Here the second draw is a white ball. So we need this only, but let us discuss and calculate all these things together. Now probability of W1 intersection W2 by multiplication rule, it will be probability of W1 multiplied with probability of W2 subject to W1. Now probability of a white ball, drawing of a white ball from the first bag will be 4 by 10, as the total number of ball is 10 in the first bag and total number of white balls in the first bag is 4. So it will be 4 by 10. Now after drawing a white ball from the first bag, that ball will be added in the second bag, and from there we have to draw a white ball. Now after putting a white ball from the first bag and taking it from the first bag and putting in the second bag, the number of white balls in the second bag will now increase by 1 more and it will become 6, and the total number of ball will be also increased by 1, that is 13. So the chances of drawing a white ball from the second bag will be now 6 by 13. So the total after multiplication will become 12 by 65. We can cancel it in some way, but we'll keep it for further calculations. In this way we can calculate all the probabilities. Now our requirement is the probability of drawing a white ball from the second bag, and I told you already, that is the probability of W1 intersection W2 plus the probability of B1 intersection W2. We need only W2 cases in the second selections, because here only we are getting white balls in the second draw from the second bag. So let's add the results that we obtained from here. 12 by 65 plus 15 by 65. Let's simplify it. You are getting 27 by 65 as the answer. Okay friends, now let's extend this problem in the next example up to 3 bags. So the question is, a bag contains 4 white and 5 black balls. A second bag contains 3 white and 4 black balls. A third bag has 5 white and 4 black balls. Similarly, as the previous question, a ball is picked from the first bag randomly and put in the second bag. Then another ball is picked at random from the second bag and put in the third bag. Now a ball is picked randomly from the third bag, and what is the probability that that ball which is drawn from the third bag is a white ball? Okay, let's try to understand this through this graphical way. Bag 1, first bag, second bag and third bag. First bag contains 5 black ball and 4 white balls. Bag 2 contains 4 black ball and 3 white balls. Third bag contains 4 black balls and 5 white balls. Now in the first draw, any ball of any color out of the black and white is chosen randomly without knowing the color, and it is put in the second bag. Then another ball is chosen from the second bag without knowing the color randomly and put in the third bag. Now we have to find out selection of a white ball from the third bag. This is the whole questions. So first of all, we need 2 events here, B and W. Let B be the event of selection of a black ball and W be the event of selection of a white ball. Then friends, we have these 4 different type of cases of our requirement, where the third pick will be a white ball. So there will be many possible cases, but we have only chosen the cases where the third pick is a white ball, and the combination is WBW, BWW, BBW and WWW, where the last one is always W. So keeping this one as W, we can only change the first and second place by W and B, and we are getting 4 possible cases: WB, BW, BB and WW. So we have thus these 3 interested cases of our requirement. Let's name it first transfer, second transfer, third pick and the probability concerned to it. Now if we draw a white ball from the first bag, it will be 4 by 9 because total number of white ball is 4 in the first bag and total number of balls in the first bag is 9. Now after drawing a white ball from the first bag and putting in the second bag, the number of balls in the second bag will increase by one more and it will become 8, but the black ball number will remain same. It will remain 4 as it was before. So choosing of a black ball from the second bag will be number of black balls by total number of balls now, which will be 4 by 8. Now after choosing a black ball from the first bag and put in the third bag, the number of the chances of getting a white ball will be 5 by 10 because here also the black ball is chosen. So number of balls, total number of balls will be one more, it will be 9 plus 1 10, but as no white ball is added here more, the number of white balls in the third bag will as remain, it will be 5 by 10, and multiplying it we will get it 80 by 720. Similarly, for all these cases you can calculate the probabilities and you can get the total probability, which will be 391 by 720. So friends, in this way you can apply the conditional probability advanced formula of conditional probability, that is multiplication rule, which is applied for the intersection of events, more than one events together. Hope you will understand this topic and you will apply the multiplication rule because it is a very useful rule for the calculation of common probabilities. Okay friends, thank you for watching.